This is R.D. Sharma solution class 12 chapter 19. Exercise is 19.11 indefinite integrals. Now this one we have 10x and sec square x we can get from here. For that we will separate out this sec raised 4x or sec to the power 4x. This integration will become like this. Under root of 10x sec 4x can be written as sec square x into sec square x dx. First thing is, before even converting this middle sec square x, I am taking 10x as dt so that we get dt equals to sec square x dx. That is the last term in this integral we got. Sec square x can be represented in the form of 10x. So this integration will become like this. Under root 10x, sec square x we will write it as 1 plus tan square x. This sec square x dx will be dt. So we will put t just now. Under root t, 1 plus t square and sec square x dx is dt. Now multiply this root t with 1 plus t square. So t raised half multiplied by 1 plus t square. When we multiply, the base is same, power gets added. So t raised half into 1 will be t raised half. T raised half into t raised 2. 2 plus half is 5 by 2. 4 plus 1 by 2, 5 by 2. So t raised 5 by 2 it will be. So the integration is of two terms. Integration of t raised half dt plus integration of t raised 5 by 2 dt. This will become t raised half plus 1, that is 3 by 2. And 3 by 2 will come in the denominator. It goes up, it will be 2 by 3. T raised 5 by 2 plus 1 is t raised 7 by 2. 7 by 2 will become 2 by 7 when it's in the numerator. So this is your final result. Only we have to convert this 10x to t or replace wherever t is there with 10x. So 2 by 3, 10x to the power 3 by 2 plus 2 by 7, 10x to the power 7 by 2 plus constant of integration. This is your final result. So this is the reference for this question and this is how you have to write. Sec raised 4 2x dx. Now sec square x is 10x. Sec square x is 10x plus there is a relationship between sec square x and 10x that we already know. And when we differentiate 10x, we can get sec square x. So we'll do what? Sec raised 4 2x. This can be written as sec square 2x into sec square 2x. Now this sec square 2x can be written as 1 plus tan square 2x. This sec square 2x comes here. Now when we integrate this, only we have to take this tan 2x as t. So this dt by dx will become tan 2x will be sec square 2x. So 2 will come outside because differentiation of 2x will also be done. That's why dt by 2 will become sec square x dx. In place of sec square dx, we will replace it by dt by 2. This is dt, half will come in front. 1 plus tan square 2x. So 1 plus t square. dt will come here. 1 by 2 will come here. So this can be directly done. That is integration of dt will be t. Integration of t square will be t raised 3 by 3. 1 by 2 is outside, so multiply it inside. I'm doing it here only. Plus constant of integration. Now t needs to be replaced by tan 2x. This will be tan 2x by 2 plus tan 2x whole cube divided by 6 plus constant of integration. So this is the way you are going to go about it. Quite straightforward. Just differentiate or divide sec 2x into sec square 2x and sec square 2x and take t equals to tan 2x. That will solve your purpose. Cosec 4 3x. Power is 4. If you understood the previous question, this is the same food with a different presentation. That means t equals to cot 3x. If you put, before going ahead, I can tell you that and you will imagine that this dt by dx will be minus cosec square x 3x. So this 3, because 3x will also be differentiated. Negative dt by 3 will be cosec square x dx. So this cosec to the power 4 3x can be written as cosec square into cosec square. So let's divide this into two parts now because the base is same, so exponents get added. Cosec square 3x into dx is already with us, which is negative dt by 3. So please do this t equals to cot 3x after this step. I showed it earlier before we actually transfer it. Cosec square 3x can be written as 1 plus cot square. So 1 cosec square theta is 1 plus cot square theta. So 1 plus cot square 3x cosec square 3x dx. Now initially I told you that cosec square 3x dx is negative dt by 3. Again, let me reiterate, t equals to cot 3x can only be done after these two steps. Don't do it earlier, before you actually reach this step. 1 plus t square cot square 3x has been converted to t. Negative 1 by 3, because negative dt by 3 we are keeping in place of cosec square 3x dx. 1 plus t square dt is t plus t square, that is t plus t cube by 3 integration. Negative 1 by 3 can be multiplied inside. So I'm just making it here only, just to save space, plus constant of integration. T can be replaced now by cot 3x in order to fulfill the commitment that t was never there. Minus cot 3x by 3 minus cot raised 3x divided by 9 plus constant of integration. This is cube divided by 9 plus constant of integration. This is your final result. So this is the way you are going to do it. Just try putting sec 4x 3x into your mind, and that will solve. Only cosec square is 1 plus cot square, and tan square 1 plus tan square is sec square. If you remember that thing, this question will be very easier for you, even the previous question. Now don't worry about this n not equal to negative 1, cot raise n. What is this? How are we going to go about it? It's quite easier than being said. Cosec square x dx is already there. Cot x differentiation is cosec square x. So if you put t equals to cot x, this dt will be equal to cosec square x dx, because dt by dx will be negative cosec square x dx. There will be a negative sign also. So negative dt will be equal to cosec square x dx. Don't worry about n not equal to negative 1, because it is already being said n equals not equals to minus 1. We will assume it to be n only. We don't worry about that. So t raise n it is. Cosec square x dx has been replaced by negative dt here. The only reason n cannot be equal to negative 1 is when we integrate this, because integration of x raise n will be x raise n plus 1 divided by n plus 1. If n is negative 1, negative 1 plus 1 will be 0. 0 cannot be in the denominator. It's undefined. How can you divide something with 0, or how can we divide something with nothing? So that's the irony here. So that's why n should not be equal to negative 1. But we'll go along with this because question is giving that. This t will be cot x. So this will be the final result. Just you have to take t equals to cot x. Other things will always come in the question by itself because it needs to be solved. And x to the power n integration function will be used. Cot raise 5x and cosec 4x. Please watch this solution very closely, because one of the question which is coming will be like this only. Cosec raise 4x can be written as cosec square x into cosec square x. Cot 5x or cot raise 5x can be written as, let it be like that, because we know that when we take t equals to cot x, dt by dx will be negative cosec square x. So dt will be equal to negative cosec square x dx. Negative will come here. So cosec square x dx will be equal to negative dt. This integration will be like this. Cosec square x dx is negative dt. What about this middle cosec square x? It can be converted into cot x, because we know that cosec square x is equal to 1 plus cot square x. It's a standard result, and cot x has been taken as t. So this cot raise 5x will be t raise 5. Cosec square x will be 1 plus cot square x. Cot x is already taken as t. So this will be 1 plus t square. Minus dt in place of cosec square dx. So negative I have taken outside, dt remains inside. So this t raise 5 into 1 plus t square will be t raise 5 dt. Second will be t raise 5 into 2e square. Power gets added. It will be t raise 7 integration. T raise 7 dt. T raise 5 will be t raise 6 by 6. T7 will be t 8 by 8. Plus constant of integration. And what is t? It's cot x. So cot x to the power 6 divided by 6 plus cot to the power 8x divided by 8 plus constant of integration. And this whole will be preceded by a negative sign because negative dt was taken, plus constant of integration. Even if this constant of integration doesn't matter when you multiply it by negative. Alright. It's also a straightforward question. The question I was talking about may be following just now. So tan raise 5x and cot raise 5x. The way or the process of solving it or integrating it will remain almost same. cot 5x and tan 5x. We will try to divide this cot raised 5x so that we get a cot x, so that we get a cosec x also, because cot and cosec has a direct relationship. I'm not doing integration. Let me just resolve this first. Once we are at a place where we can directly integrate it, then we'll take that sign integration and dx and dt. So cot to the power 4x into cot x, this can be written as cot raised 4x can be written as cot square x into cot square x, and cot square x is equal to cosec square x minus 1. So either you say cosec square x minus 1 whole square, which is cot to the power 4x. So this is simply cosec square x minus 1. This is cot square x. But cot 4x will be the square of this term, cosec square x minus 1 whole square. So cot square x, cosec square x minus 1. And cosec square x minus 1 whole square is simply cot to the power 4x. Okay. So we'll open it using a minus b whole square. Cot x is already there in the later part. So a minus b whole square, a square plus b square minus 2ab. So cosec square x whole square plus 1 square minus 2 cosec square x. I have not yet multiplied this cot x. So let me multiply it. Cosec to the power 4x. Now you have to include cot x. You cannot just leave it. So multiply this now. Cot x plus 1 into cot x, that will be cot x only. Minus 2 cosec square x and cot x. Cot x should be first, but let it be. Now we will divide, because this is the whole integration we have to do. Cot x integration directly we know. And cosec 4x cot x and cosec square x cot x we have already done just now. Okay, in this exercise we have completed that. In somewhere in between this might have come. So we will separate them out, integrate them separately and try to add them in the final part. We are integrating now. All have the integration sign. All have the dx along with this. I2 will be direct. I2 will be, see, this is cot x dx. This is simply cos x by sin x. If you take sin x equals to t, cos x will come. So cos x dx will be the result of sin x equals to t. That is 1 by t, dt by t, log t. T was taken as sin x, so log sin x. This is how it has come. So I2 we have already done. Next one will be I1 or I3. We can take any of it. I3 will be, I'm not taking negative 2 sign right now. It will be cosec square x cot x. Now when we take this cot x equals to t, this dt will give you, dt by dx will be negative cosec square x dx. So negative dt will be cosec square x dx. Cosec square x dx will be equal to negative dt. And cot x we have taken as t. So it will be negative dt. Here negative I have taken outside, and this will be t, only t, because cot x is only 1 there. So negative t square by 2 plus constant of integration, call it as c2. So t was taken as cot x, so it will be negative cot square x divided by 2 plus constant of integration. It can be c2, you can write it as c2. We'll combine this c1, c2 and the c3 coming from I1, and we will just call it as another constant, which is capital C. Coming to the third part. I3 was already done, I2 is already, I1 we are taking. So assume it to be I1. I have written I3, but it is I1. So I1 will be cosec raised 4x into cot x. So this question was directly we have done in the previous few questions. So cosec square x into cosec square x for cosec raised 4x and cot x. So cot x, middle cosec square x, we have converted it into 1 plus cot square x. So we have 1 plus cot square x and cot x. The first term, cosec square x, I am taking in the last with dx. Why it has been done? When we take this t equals to cot x, if you remember, negative dt was cosec square x dx. Negative dt was cosec square x dx. It is negative dt. So this integration will become negative dt. Negative will come in outside. Dt cot x was taken as t. 1 plus cot square x will be 1 plus t square. Cosec square x dx is negative dt. Now multiply this inside. T plus t cube. Now let us integrate it quickly. This t will be t square by 2 plus t raised 4 by 4 plus constant of integration. We have taken it as 3, C3. Negative was outside. So let me write the final version. Replacing t by cot. So cot square x by 2 minus cot 4x by 4 plus constant of integration C3. Now we will combine I1, I2 and I3. So I am writing the final thing. You can call it any of them as I1, I2, I3. It's up to you. It doesn't matter. You just have to combine them finally. When you combine them, don't forget about the sign here. So cosec 4x into cot x gave us negative cot square x minus cot 4x by 4 plus c3 or c1 you can call it, because c3, c1, c2, c3 all are intermingled now. So minus cot square x by 2 minus cot raised 4x by 4. This is the first term. c1 plus c2, c3 will eventually be called as capital C, that we will deal later. Cot x integration was direct. It was log modulus sin x plus some constant that will take it outside. The last term actually. What is the third term, which is cosec square x cot x? Negative 2 is already there. So when you multiply this negative 2 with this 2, this negative will come, negative will become positive, and 2 will get cancelled. So only cot square x will remain. Cot square x minus cot square x by 2, that can be combined. That can be added or subtracted. So 1 minus half actually. If you take cot square x outside, it will be 1 minus half, that is half only. So cot square x by 2 it will come. So first term will be the highest power, which is cot raised 4x by 4. And when we combine these two cot square x terms, we got cot square x by 2. Third term is log sin x, log modulus of sin x. And then c1 plus c2 plus c3, that is combining all constant from all the 3 i1, i2, i3. We combine them and call it as capital C. That's your final result. So this is the way you can do it. This reference may seem different. The approach may be different, but ultimately you will get the similar result if you follow what I have advised you. So we have gone one level up now. Cot raised 6x. So this kind of question like cot raised 8x or 7x, all this can be easily integrated. But the only thing is that the time it will take, because it cannot come in examination, because it may take a lot of time, say 10 to 12 minutes it may take for you to solve this question. So that's why you need to solve this kind of question with certain tricks. And those trick is cot is related with cosec square x. You have to see what value can give what differentiation result and what value can give you what integration result. So this cot 4x into cot square x will form cot raised 6x. Cot raised 4x remains like that, and one of the cot square x will be written as cosec square x minus 1. So now multiply this cosec square x inside. When you multiply this cosec square x inside, cot raised 4x into cosec square x minus cot raised 4x. Cot raised 4x was already done by us, if you remember. Don't worry, we are going to do it again, but I'm just recalling that you must understand that this already being done, so that you get some experience of that thing which you can apply here. So cot raised 4x can be written as cot square x into cot square x. Cot square x can be written as cosec square x minus 1, and cot square x remains like that. Now multiply these, it will form cosec square x minus cosec square x into cot square x. So when you multiply this can be written as cot raised 4x, because this will give you a direct solution. Wherever we have cot and cosec, that can be easily solved. How about this cot raised square x or cot square x? This cot square x can be written as cosec square x minus 1 again. The last one I'm talking about, which I'm pointing at right now. So it can be written as cosec square x minus 1. When you multiply this with negative, the sign will get changed of whatever is inside the round brackets. So the final version of all these transformation will give you cot raised 4x into cosec square x, the first term. Cot raised 4x has given us this one, but because of the negative in front of cot raised 4x, all the signs will get changed. So it will be cosec square x into cot square x minus cosec square x. And this minus cosec square x will change the sign because negative was already there outside. Plus 1 will become negative 1. All this can be easily solved now. Please remember, when you are solving it, you have to departmentalize these into I1, I2, I3. Do I1, I2, I3 separately and then combine at the last. This is called the divide and conquer way of solution in mathematics. So everywhere there are 4 terms we have made now. Integration of dt will be t only. So the last one I am telling you, it's integration of dx it was. So it will be x only. Integration of cosec square x dx will be directly cot x. It is negative cot x. So the last one will be x. The second last one is negative cot x. Because the first and second term will want some assumption. So the assumption remains same for both of them. That is t equals to cot x. dt will give you negative cosec square x dx. Here also dt will give you negative cosec square x dx. minus dt will come here, minus dt will come here. Cos x square dx will be negative dt. So minus goes out in the outside. Cot x was taken as t, so t raised 4. Please remember the sign also. These is different, this is different. Now I am doing the second part, a second term of this one. Cos x square x into cot square x into dx. Cos x square x dx will be minus dt. So minus I am taking outside, and cot square x will be t square. So the first term will form negative t raised 5 by 5. Second term will give you negative t cube by 3. So now replacing t by cot x, it will be cot raised 5x by 5. The second term will be cot raised 3x by 3. Negative sign is there. We'll apply this sign just now. Let me combine all these 4 terms which we have got. Now I'm adding all these 4 terms because the integration has been done. The first one is the first term, so negative will be there. Negative cot raised 5x by 5. This is negative, so negative will become plus. So let me make a big plus in between. The third one is negative cot x. The fourth one is x, so it will be plus x. And all these 3 or 4 terms that will give you a constant will be a final constant. So this is your final result. Now how you are going to write it and do it in a formal way, that you see just now. So it will be like this. You have to use integration and dx sign everywhere. Whenever you are dividing also, then also you have to stick with this integration and dx sign. Don't forget about the negatives and plus. Divide and conquer. So divide them into I1, I2, I3, I4. Don't worry about if they are saying I1 and I2. Someone is saying I1 and I2 and I3. Make it as I1, I2, I3, I4. Doesn't matter. And then combine them, and finally constant will be some final constant. So this is all about this exercise. Thank you so much and have a good one.